All right. Hello, everybody. How are you doing today? Today we're going to take just a few minutes as we begin our or begin our chapter on talking about waves. And of course, this is part of our Oceans Part 1 unit. So specifically, we're talking about ocean waves. However, um, we are going to talk about the fact that really ocean waves have a lot in common with other kinds of waves. And when I say other kinds of waves, I'm talking about things like sound waves or light waves, um, microwaves. And no, I'm not talking about a microwave oven, but a microwave oven uses microwaves to cook your food. So microwaves are a type of wave. There's also X-rays are a type of wave. Radio waves are a type of wave. In fact, cell phones and a lot of electronics use radio waves to communicate information. Um, there are a lot of different types of waves uh, in our world. Many of We can't actually see waves, and the reason for that is because waves are just energy. All right, energy is not something that we can see. However, it's energy that moves through a substance, and we're actually going to write that definition on our paper. You can either put it up at the top of your paper or down at the bottom, but we're going to write a definition of the word wave. So, a wave is energy moving through a substance. Moving through a substance. And sometimes that substance, oftentimes, we refer to that as a medium. Okay, kind of like in art, you have different mediums that you work with. You might work with the medium of paint, or the medium of charcoal, or the medium of pencil, or the medium of stone if you're carving a sculpture. So it's still all art, but it's art being done through a different substance or a different medium. Well, waves are energy that move through different substances or different mediums. In this case, in our unit, we're focusing primarily on ocean waves because this is a unit on about the ocean. So we're looking at waves that move through the medium of water, specifically salt water. However, waves such as light waves can often pass through glass. A lot of times they're passing through the air, moving through the air. Sound waves also move through the air, but can also move through a door or a wall or all sorts of things. So, um, a wave is just energy moving through a substance. In this case, we're talking about energy that is moving through water. So, we're going to take a look at different parts of a wave. And so, let's get a different pen up here for right now. And so we're going to start by looking at the highest point in a wave. And what is that called? Well, the highest point in a wave is called a crest. So you're going to label this on your sheet as well. And if the highest point in a wave, and this is any kind of wave, but again, we're talking mostly about ocean waves, but this is true of light waves and sound waves, microwaves and radio waves, and all of those types of things. The highest point is called the crest. The lowest point is kind of a strange word because the English language is strange, and so a lot of people have trouble pronouncing this one. Trough is pronounced trough. Okay, so the lowest point in a wave is called the trough. Now, we also have a name for the distance between two consecutive crests or two consecutive troughs, and that particular name is called a wavelength. It's just one word, wavelength, compound word. But that is the wavelength. And so different types of waves have different wavelengths. Some of them are very close to, the crests are very close together, others are very far apart. We also have a name for the distance from the crest down to the lowest point, the trough. Okay, and that particular name is wave height, which is actually two words. Wavelength is one word and wave height is two. I cannot explain to you. However, um, we have wave height and wavelength. Okay. We also have a name for, we'll put it over here, this dotted line right here. Now, this particular name is fairly unique to the ocean. Okay. Uh, this name would have a different title, or this line would have a different title um, depending on what kind of wave you're talking about. But in this case, I'm talking about ocean waves. This line that runs kind of through the middle of the wave, this is called the still water line. All right. So the still water line. In other words, if the wave were to stop, this is the line where the water would be at rest. Okay. The final line that we're going to take a look at is the line way down here at the bottom. And I know yours looks a little different from mine because yours is kind of a line with two dots in between. So interesting kind of dashed line. I didn't have that option on this particular whiteboard, um, but we'll give this here, this title, this line, the title of the wave base. And we're going to talk more about wave base in the next lesson. All right, but this is simply giving you an opportunity to see some of these different terms and to know where they are as part of a wave, because you'll hear us refer to these different things over the next couple of lessons. All right, ladies and gentlemen, make sure that this paper goes into your current unit of your binder.